Hello, welcome to Equals Math Administrator Support Training. I'm Karen Ross Brown, Director of Curriculum Development and Training at AbleMath. Let's begin. We all know that learning happens when students have concrete models and examples to follow, when they use language to understand, talk, and think, when they connect new information to what is known, when they engage in activities that active learners do, such as performing actions and using language to talk about it. And we know that students take in knowledge that is connected over time. So it is important when teachers first think about teaching their students math that they consider when we want to ensure that students are learning, it's important to make a commitment to the idea that all students are active learners who observe, think, act, and talk about it. So essentially, we're raising expectations. In order to assist students in meeting those expectations, we need to ask, as teachers, what does learning look like for my student in this lesson? And how can I make it happen? Let's take a look how opportunities presented in Equals Math lessons do support that idea of making it happen for students. In looking at this example of lesson 2B2, student will construct sets of 5. I see a 4-page lesson. Every lesson in Equals has 4 pages, beginning with activating and building background knowledge, introducing and connecting to new vocabulary and solving problems, reviewing with the representations of concrete, semi-concrete, abstract, working on problem solving again, with discussion and close at the end of page 3, and then page 4 is practice and application. What you're seeing that is color-coded here are opportunities for students to learn action words and connect them with the idea of cause and effect that is happening with the particular lesson concept. Reviewing new and review vocabulary from previous lessons, and that shows up in green, as you can see here, across all 4 pages. So action words and vocabulary repeated multiple times. You also see what is in orange here would be problem solving support, such as tools and strategies, but also problem solving itself with a model and as a group and independently and as a group again, and showing up again one more time on that last page. And then finally, what's in purple here would be communication opportunities, discussion, working with a group, discussion again, close activities to show what I know. Also, sensory, real world, and partner problem solving, plus games. All of those things have opportunities for discussion. Essentially, what we have here are consistent opportunities to learn vocabulary, to view models, to be a part of a shared experience and other experiences, not just one, but other experiences as well, communication opportunities, interaction, and actions which reinforce the idea of cause and effect. So essentially, the lesson is a deliberate, systematic order of activities to meet best practice instruction requirements as we pulled those from general education and supported with built-in adaptations for students. For a moment, let's take a look at prerequisite skills within Equals. Chapters 1 through 10 represent an ordered lesson structure that begins with pre-readiness to the end of 4th grade. Within that set of ordered lessons, you'll see connections within and between the National Council of Teachers of Mathematics identified content areas: numbers and operations, data, geometry, algebra, and measurement. Let's take a look at an example of that. In looking at Chapter 2, Section B, I see that Section B is about demonstrating number sense with numerals and amounts to 5. So essentially, students are learning about amounts to 5 from 0 to 5 throughout, and then towards the end are subitizing amounts and also beginning to learn about equal amounts. So after this section, students move on to graphing sets to compare. So we're taking the idea of comparison that has been started in section 2B and continuing it here. So students are learning about now not only equal amounts, but more and less as well. Students are creating sets and learning about joining and separating sets of amounts 1 through 5 and comparing the results. So students are taking what they've learned about sets 0 through 5 and are applying it here to additional skills that are related, and then construct an object graph to compare and a pictograph, bar graph, both of these bar graphs to compare. Now, what the object bar graph and the pictograph bar graph have in common with everything else that the student has learned so far is that the amounts are limited to what the students are familiar with. You will see also repeated vocabulary, action words, tool use, and strategies throughout the lesson. We also need to remember that math is communication and problem solving based, and that there's an emphasis on using provided strategies for solving problems, but also the students' ideas in that sense of community. As a group, we're learning together how to solve this problem. So the focus isn't on right or wrong answers, but rather, how did we solve the problem? Did it solve the problem? And if not, let's try something else. Essentially, students are learning to decide what works to solve the problem, right? The idea of cause and effect. Think, do, watch, and talk about it. I also want to mention the benefits of a group model, as it is a part of the experience in equals for students to be with the other students, which they like very much. They do need someone to talk to about math. And it's helpful if it's not just the teacher, but it is other students as well. And whereas this might not always be possible depending on how far apart students are, but if they're fairly close together, grouping students together is a compromise and should be utilized because of the benefits. Okay? Math is a very social activity. It should be taught as one, which ends up providing opportunities of high interest and fun for the students, and truly they begin to love learning math. So let's take a look at just a bit of the lesson terminology that you might not be familiar with because it is very specific to equals. In teaching vocabulary, concrete connections are provided within the lesson and are created with the student, so they have that experience. Understanding vocabulary is an indicator of success in whatever subject areas students are learning in, so it's very important. Vocabulary is paired here with these concrete connections with a picture symbol label and a matching card so that students can become familiar with it. There's a definition that's provided, but that is for the teacher to take and adjust it so that it is in language and the amount of language that is understood by the students. But the vocabulary words themselves need to be left as is because they are repeated across the entire curriculum. Teachers can use concrete connections as a way to assess understanding of vocabulary by giving choices and asking the student to find, for example, show me what pattern looks like. The student can choose from these. Okay? Also, students could demonstrate what a particular word means as well. Number notes, there are two kinds of number notes. We've seen number notes show up as a group activity, so in poster format, and then as an individual activity. In looking at the group activity, this happens at the end of page 1 within a lesson component called show and tell. So the students are taking what they have learned so far on page 1 and then talking about it by way of a very structured conversation that includes a model from the teacher. So the teacher is demonstrating the first step by saying, I know I can show a set of 3 and 4, okay, and then writes that down and shows an example of each. Then ask the students, what do you know about sets of 3 and 4? What's important here is that the materials that I used, I took from the table. These are the materials the students have been using during this whole first page. So students are familiar with them. They know what they are, and that makes it part of this shared experience that they've had. Now they're talking about that shared experience. So I ask my students, what do you know about sets of 3 and 4? And the students might eye gaze to something and I'll say, oh, yeah, we could count those blocks as a set of 3 and match them up, 1, 2, 3. Students might choose the other card on the table that is representative of 3. That's, oh yeah, that's 3, 1, 2, 3, and place cubes on it. Another student might match the circle counters on the card that I had placed. Or another student might find blocks that match. I ask then, what do I want to know about sets of 3 and 4? And I might say, I'm wondering, could I use my fingers, 3 fingers, and match them to make a new set? Could I do the same with 4 fingers? And then I ask my students, what do you want to know about sets of 3 and 4? Maybe it's a student who's looking at some books on the shelf, and I'll say, oh, you're right, we could count sets of 3 and 4. We could match sets of 3 and 4 books. Another student might point to the markers that are sitting on the table and ask if that's a set of 4, or match up that set of 4 with the cubes. Any of those things work. We want to include students that what they're saying is represented. So as soon as they do that, and no matter the way they do that, whatever that might be, they are recognized then as part of the group. The second time number notes shows up it's at the end of page 3, where students are documenting what they've learned. So using their pre-writing, scribbles on the page, using pick symbols, objects, we can take a picture of it, whatever they use to tell what did they learn, that's what's going to go on their number notes. A math focal point is part of equals only if the teachers choose to use it. It's something that we came across in a classroom and thought it had a great amount of value, that we would pass it on to the teachers. The idea of math focal point is to provide a place for review. That's an important part of the lesson, is to have that review at the beginning. So you can see the teacher used a math focal point for 3 different groups that she has here. And here I can see a portable whiteboard. A teacher is using that for a math focal point. Teacher can choose what to place in that math focal point. So here is an example that I created here. I could put my concrete connections. I could set those in my marker tray if I wanted to. I can put up the vocabulary words, the number notes we just learned, the daily schedule, any poster or work mats that we have, the solve poster, student work, anything can go up here. It is up to the teacher. But the idea is that, first of all, I can store the materials visibly in front of me that I'm using in my group. And it's a lot easier to take that down and use it with the students and put it back up than to dig for it, right? So it is a convenience for the teacher, and that's great. But the benefit for this for the students is more important. And that is, it's a way for students to review. First of all, it's a nice reminder and everything's right there. And we've seen this before. It's a really very effective way to provide review, but it's also an effective way to provide connections to the concepts students are learning. So if they see something in the hallway, or as a teacher, I point that out to my students, that, hey, we're separating parts, we're joining parts. Here's an example of that, and bring it in. Or I might ask them to bring something in as an example of that from home. Whatever that is, the math focal point is a worthwhile thing to do. But if teachers review in another way, that is really entirely up to them. The action dictionary is specific to equals, to actually AbleNet curriculum in general. But in this particular case, it is related specifically to equals. And essentially, the action dictionary is a way to find adaptations for students who need them to support their motor skills, their language, their attention, their cognition, their vision. So for an example, you can see this is the page for add. This is not to teach the student how to add, but rather how to give students access to the tools so they can add. You see an example of this for the student is, oops, that's going pretty fast there. The video is going a little fast there, but the student is sliding tabs on here with connecting cubes attached to the top. Added 3 and then 2 more to equal 5. And that's something that the student could access. Perhaps the student is having a hard time controlling manipulatives on the table. They go flying off, right? So here they are anchored to a tool, and students can add that way. So that's an adaptation. Here's an adaptation of using, that you can see at the bottom, of using angle legs, which are included in the kit as a way to create new shapes. They snap together, but here they're being used as borders so that the student can then see in a concrete way where those borders are to make sense of them. And then also the student needs to slide materials from the whole to the parts. They can do so more easily without it flipping off the side. Action cards are included in every single lesson. There are 3 identified, and they are related to the strategies. These are repeated in subsequent lessons, so you see them throughout the lesson, and they will show up again and again and again. These are demonstrated to students multiple times throughout the lesson so they can see that, and they can also take a turn so they can feel that as well. So the action cards, for example, would be, for this particular lesson, be move, place, and count, and they will vary just depending on the lesson. So how they are used in the lesson are by way of the teacher, as I said, modeling and repeating that modeling, and then strategies, that connection to the strategies as well. In the blue circle here, you can see on the first page how there's a reminder for the teacher to provide that model. So you'll see it here. It's above that in Math Dash. It's below that in Math Tools and in Number Notes, and you'll see it page after page. Also, what you see here are, what I circled here are purple words in the lesson, and there's more than that, that show what students are expected to do within the lesson in addition to those action words. So the student is asked to show something, to place something, to answer, to explore, right? And so if a teacher needs to provide an adaptation for the student, they get forewarned, right? That that's something that the student will need in that lesson. However, that's a lot of actions when you look at the entire 4-page lesson. So we suggest that teachers add 1 or 2 of those supports slowly so that they're not bombarded with having to do all of that work. It's also for the students too, right? We want to give them 1 step at a time, 1 action at a time, so that they don't feel overwhelmed with all of these changes. However, I can provide access to that action so the student understands it by providing hand under hand support. So if that action isn't adapted, hand under hand support is a really good second to be providing that for students so they get the idea of, when I do this, this happens, right? It's a cause and effect connection. Let me back up a second. Here we go. We are moving on to a different lesson here, and this is lesson 2C3. The student will join and separate sets of amounts 1 through 5 and compare the results. Just going to walk quickly through a lesson so you get a feel for what is here. On the very first page, we begin with warm-up and activating background knowledge by reviewing vocabulary from a previous lesson, happens to be more and less, and also a game from a previous lesson. Next is Math Dash, which is also building background knowledge, but often there is a connection to a past lesson as well. So I like to think about Math Dash as a connecting activity. This is where the action cards are introduced first, and the students have a chance to either have that, use those actions with an adaptation, or again with hand under hand so they understand it, or perhaps they don't need an adaptation at all. That's very possible. After Math Dash, we're moving on to Explore and Connect. So now we're moving into more building background knowledge here, beginning with poster and cards. The poster, as you see here, is of a backyard. The idea of having a poster is to provide a context to the problems that are provided within the lesson. It's also a wonderful real world connection, and the posters are interactive. Here's an example of that in the backyard. I can see an example of join and separate here. Actually, it's a separate. I see this bird feeder separating these two birds. I can walk through here and find other examples. I can also use manipulatives from the kit. Here we have baseballs that are similar to the balls that are on the page, and rocks, which is something that you would find in a backyard. After the student has had that experience, we're now moving on to math tools. So these are tools that are introduced or brought back. Students might have seen these before. We want students to see the use of those tools connected with the strategies and use of the new vocabulary, but it's all pretty informal at this point, right? Students have experience with it. It's a modeling by the teacher, but it's also some free exploration after that. And then provided is that show and tell that I talked about earlier with the number notes poster, where there's that structured conversation where students can talk about what they know at this point. Now we're on the third page and we're introducing and connecting, beginning with the new vocabulary that was informally introduced on the first page and that second half of the page. And the words here that for new vocabulary are join and separate. They're the concrete connections for join and separate. After that, problem solving begins with a problem solving model where the teacher is using the solve poster to think out loud and show exactly what that thinking looks like. So we call that visible thinking. There are problem-solving questions, as you can see circled here, that match the poster and also match the sequence of walking through that poster with examples for the teacher. So there is a strategy that is identified for the teacher to use because here we have examples that we want specific to that strategy. So teachers need that support. It is present. Essentially, we're pulling together everything the student has had so far. Actions plus tools plus strategies all come together here. Teacher demonstrates one strategy and then repeats the whole process with a second strategy. So essentially, as I said, the solve poster has the problem-solving questions for identifying facts, action, an estimate or prediction, tools or strategy that they want to use, and what is the solution at the end of it. So it's essentially, as I said earlier, what does it look like to think about and solve a problem? There are representations here of actions by action cards, concepts with vocabulary cards, and actions sometimes as well. Concrete connections are here. Also, writing what we're learning, objects that can be used on this solve poster or pick symbols, also work mats and tools available. So everything that the students have used so far are going to show up here in this model that you see. It's also going to show up in the next section where you see solve it together. This is a problem-solving process where some group decision-making takes place. As the teacher, I would be guiding my students through this process twice. First with the strategy that they choose, and then with the other strategy, and we talk about it. Again, all with the materials that they have seen before, right? They've used these tools. They've seen the action cards before, the other tools such as a part, whole work mat, ever those materials they will be present here and on the table. On the third page, the concept is reviewed in a concrete way, a semi-concrete way, and an abstract way. Students can try out whichever one they want to try, and it's interesting for the teacher to see if that's changed. Right? If a student is leaning more towards semi-concrete than concrete, is the student understanding semi-concrete representations, whereas before it was only concrete? It's kind of an interesting formative opportunity here. You can see that in the representation, we have rocks, backyard, right? Actual rocks, picture symbols of rocks, and then amounts that represent those. Now, if rocks are not a good idea, of course, the teacher can always make thoughtful substitutions. So there is a little leeway there because it's not always a safe thing for students to use. That would be entirely up to the teacher. That's followed by a skill worksheet, which is essentially a paper pencil view of what happened objects can be provided with that. Problem solving follows. Now this is, let me go back. Problem solving follows for individual students now. So I'm there as a teacher to support my students as they solve the problem. There is support at 3 levels. There is a problem solving worksheet at 3 levels to support student recording the outcome. So that's what's happening here. You can see after that there's a problem solving discussion. How did you solve the problem? So you find out, how did you get that solution? What did you do? And students can actually show what they know. There is also the group problem challenge. That's changing an irrelevant fact in the problem and see what happens. Does it change the outcome? Changing a relevant fact and then see what happens. What happened to that solution when I changed a relevant fact? I need to provide my students at that point. Oh, let me back up for a second. With the solve poster, there are student-sized solve posters. There's also 2 large posters. If the teachers want large posters for everyone, they can have them. They have replacement materials in their members-only content. However, if the student knows the process and doesn't need to follow that, that's acceptable too, for sure. Students can try their own strategies if they like. That is up to them. I would encourage students to do that. If it doesn't turn out, then we talk about it, and we do so in a way that feels like a supportive group encouragement of trying something new and seeing what happens. I recently heard a teacher talk about how a student did choose something different, a different tool to solve the problem. And when the other students saw that, they were very excited and wanted to try it as well. That's what we want math class to look like. At the end of page 3, Math Dash is revisited. And that's a nice opportunity for some formative assessment for teachers to see, are the students doing this differently than they did prior to learning all that they've learned so far in this lesson. Also, what did the students learn? There's 2 opportunities to do that. There is the opportunity to show what they know. There's a guide with the I Learned work mats to show support, right, for students at levels 1, 2, and 3. So it lays it out for the teacher what is required for each student who needs that kind of support. What did you learn? Show it in the different ways as you get higher into, say, level 3, you show it another way, that kind of thing. So that's one way. The other way is through the number notes, as I talked about earlier, with pick symbols, with pre-writing kinds of skills, real objects placed, we take a picture of it, whatever works for the students there. And then finally, on the last page, there are multiple opportunities for students to practice and apply what they know, what they've learned. The teacher decides which one of these the students are going to use, how many they're going to use, and how often they're going to do them. And so that is entirely up to the teacher. They need to follow pages 1, 2, 3 in the exact order on each page as given to them. When they get to the 4th page, they get to choose. So you'll see sensing math with using any of the 5 senses, sometimes more than one, real life connections, classroom connections in the greater area of the school grounds, community, internet, right? All sorts of opportunities for students to connect to real life problem solving. There's also partner problem solving, as you can see with the template here, based on the problems the students have solved so far, and then 2 games. So that's a summary of the lesson very quickly. You can see how the lesson flows and flows really easily and is built on repetition over and over throughout in different ways, where the students are encouraged to generalize what they know. So in talking about supportive students, let's just take a closer look at the interactive multi-purpose materials and manipulatives that are in the Equals kit. So first of all, the manipulative counters, you've already seen these. These connect to the themes and problems in the lesson. So you'll see these connecting to pet store with turtles and dog toys such as balls and frisbees. Would be ocean animals to the ocean theme, but both ocean theme, butterflies to backyard or rainforest, right? all those connections are made. But we also bring in generic representations pretty close to the beginning of equals. These are introduced so that students get the idea that I can use this too, and this we can pretend that this is something else, right? In order to solve that problem, we can pretend. But having these connected objects are very, or counters, I should say, are very motivating for students. They get excited about it. It's kind of fun. They're interested in it, and they're very close to what they are solving a problem about. The representations look like what is in the problem itself. I also wanted to point out supporting communication, because we know that not every student has a device that includes enough message locations to include math vocabulary or tools that are used during math class or what's happening, right? So in order to support students' communication about what's happening in math class, we want to give them an enhancement. So yes, they absolutely should have their devices with them at all times. I absolutely 100% believe that is the thing to do. But also we can provide displays of objects that are that can be used as answer choices. I can use this place value chart that we use as a pocket chart. It's included in the kit to give choices. I can put them on a tray. I can give 2 or 3 choices as a teacher, any of those. And there's some students who can't point to the answer or pick it up or touch it or eye gaze to it. I had students who could do none of those things. So recording, that's the one I want, and I do the pointing, truly does bring in every student can take part in that conversation. Okay, so let's look a little bit more now into interactive access for understanding lesson concepts and strategies. I already talked about this a moment ago. Just another example of the theme poster. This one's rainforest. You can see butterflies and insects here and cards where students can interact, use these for answer choices. When I ask, what are these? The student could use the cards as an answer choice. We could create a set of 5, let's say, from the butterflies. We can circle 5. We can count out 5 butterflies. We can match them up. So many things that we can do here to emphasize not only the theme itself, this particular animal environment, but also the materials from the lesson. Another way that the students can use the step-by-step communicator is to count. So this includes 120 minutes of recording. I'm sorry, not 120 minutes, 120 seconds of recording time on the step-by-step, which means I can count from 1 to 100 on there. I can record that so that every time the student presses the button, another number is spoken out loud. So I can place a butterfly on this tray, anchor all this to the table. The student can sweep it into the box and then say 1, the step-by-step, and so on. For students who have a problem with keeping materials on the table, that's sweeping these off the tray, we can put Velcro on the bottom, let's say, of these cubes, and Velcro on the tray, and the student then can push these to the Velcro to sort them. That's one thing you might find, or that you would find in the Action Dictionary. Then I love this number line because it emphasizes something that I remember not really knowing how to do as a child when I was learning math. I thought of the number line in this way, that this is the order of numbers, right? And I'd place objects to represent that, but it didn't really make sense to me. However, the number line isn't meant for that kind of thinking. It's meant for this. This is not 8 because it's after 7 and before 9. It's 8 because it's representing the amounts from 0 through 8 on the number line. So we had this created so that tools such as the foam tiles could fit between the numerals to show that, to support that for students. Also, the money cards fit between, and the connecting cubes as well. The connecting cubes also fit on the individual squares of the hundreds chart, which goes to 120, by the way. So they can see that this is a set of 10 that's single, right? Not connected, single items. But I can also show them connected into a bar of 10 that I can use to support what I'm learning in place value. Cookie shapes can be used to create an object graph. So these are actual, we're talking about cookies. They're shown on that object graph as cookies. Here's a representation using color, the foam tiles. Part whole work mat works with, it could work with pick symbols, it could work with numbers, it can work with actual objects as students join and separate. I can use the start change result work mat to show that when I have a change in addition, it's different when I have a change in subtraction. Students can learn about quarter and half that of course we need when we're learning about the clock. By looking at the 4 quarters of an hour and the halves that you see of an hour, and then represent the minutes with Unifix cubes. It's that large. The teachers are able to do that. So now we can count how many minutes are in a quarter hour, how many minutes are in this quarter hour, and how many minutes are in this half hour, and so on, all the way around. Oops, a little bit too far there. All the way around the clock. It makes telling time as concrete as we can make it. This work mat is for students learning about division, where I know that I have 4 groups. It says it in the problem, 8 divided by 4 groups equals blank. I need to find out how many are in each group. And then I can place one at a time, each of these counters one at a time, and find out there are 2 in each group. But I can also use the work mat if I don't know how many groups there are, because I know there are 2 in each group. So I place 2 in each group. And when I'm done, I can see I have 4 groups. The math line, I already talked about the math line, being able to handle having the manipulatives attached to the top of the tabs with Velcro. I would put the soft Velcro on the manipulatives and the hard side on the math line. They work for all of these counters. Even the baseballs, which seem a little large, we stagger them back and forth, they work. We have the 10 frame boxes. There are 12 of them. Students who need support with vision, especially students who are blind, can use this opportunity to understand what a 10 frame is all about. Often students who are blind learn to count with their own body parts, so they can have that connection. And then they need to connect that out to the world. So I could even have my students place these Unifix cubes on the tips of their fingers and then connect to their body and then out to the world in this 10 frame box, which can be used to understand amounts from 0 through 10 in relationship to 10, but also snap it shut and move it to the tens place, because they can use these for understanding place value. As I said, there are 12 of them, so they can get that beginning understanding of what place value is about. But we also have paper 10 frames as well. Again, the angle legs come in handy for providing borders, so students can find specific numbers on a hundreds chart that looks kind of like a lot for some students. Narrows helps them narrow it down. For students who are learning to sort, angle legs can be secured on the table or on a work mat with sticky tack, something like that, where the students have a place to just move objects to. And they're essentially matching, but as a beginning sorting activity, that makes a lot of sense for students. You can even use angle legs to create a tool so that students can more easily find and mark a coordinate. Also, teachers can use the blocks that are included for students to be able to use pick symbols and just merely tape them on a set of the blocks. There's a lot of blocks so that they are able to do that. And circle counters are present as well. Oops, let me back up for a second. They're double-sided, but they're larger, so they are not a choking hazard like the small ones that you typically see in a classroom. I also wanted to point out the idea of using concrete support in problems so students can identify facts right from the problem and place them on the solve poster. I use sentence strips and a double-sided easel pocket chart, and I had to reduce the problem, make it simpler, and teachers can do that. And then this makes a lot of sense for students who need that concrete support. And then they can solve the problem and identify facts and use the cards to identify the actions they've seen. They can make an estimate or prediction from answer choices. They can choose which tool to use or which strategy to use given choices, and then identify how the problem was solved. I would like to show you a couple of brief videos so you can see what this teacher is doing, first of all, with the students. For the beginning part of Equal, she has not used it before. This is new to her. So this is in the first year of implementation. And especially watch this little guy with red hair. You'll see him in the next video, which shows them a year later. So you can see how she's helping the students to take part in this in a very structured way. So let's just take a look at this quick video.
I got turtles. Oh, can you have the snake put the turtle in the bag for me? Oh, have the snake put him in the bag. Thank you. This is a set. Okay? Thank you. I have a set of turtles. I have a set of turtles. What do I have? Good. What do I have? Oh, that was loud. What do I have? What do I have? You said it. Say it again. Set.
Now, what I like about this teacher is that she's involving all of the students and she's providing a communication opportunity for the students, even if they have their own device. What I'm guessing here is that the device they have in front of them does not have the word set on it. So she's providing another way. And as you can see in the next video, this really pays off. 1 year later.
All right, are we looking?
I'm gonna stop it just for a second. 1 year later, the teacher is using the action cards I talked about earlier in a different way. I loved her creativity here. She is using it as a way to provide direction for her students during this activity. The students are learning one and many. So on the work mat in front of the student, the girl's, her head is in the way. There is a set of one, I believe, drawn on and a set of many here. It's just hard to see on the video. And he's going to be asked to identify, which is one and which is many. So the teacher has an idea of how this is going to go, but then the student has his own idea. And I really love what happens here.
Are we looking here? Are we looking here? Are we looking over here? Oh, you're going to compare? Okay, how are we going to compare these? Are you going to compare by matching or labeling? By labeling? Okay. So then show me how you label.
That was really nicely done. So she not only was using the cards to communicate with him, but he in turn used the cards to say, hey, I want to do it my way, and this is the way I want to do it. So that was incredible to me. This is 1 year later. The video says progress and engagement for sure, but also the creativity of the teacher to use these action cards as a way to communicate and then have that open to her student communicating back to her. So let's take a look at the teacher observation portion. Essentially, you need information before the observation so you know what the teacher is going to provide the students. It just makes it easier. It's not, you don't have to have 100%. If you don't have it, you don't have it, but it does help this process quite a bit. So you would ask for a copy of the lesson components or component the teacher is going to be providing when you come in to observe. And the teacher might be teaching a lesson component on one page and then move on to the next page. So it might be more than one page, but at least you'll know pretty much what to expect looking at that. I do have an example here today for lesson 1C10, page 1, Math Dash. And this lesson is student will identify two-dimensional shapes, and those two-dimensional shapes are rhombus and rectangle. Before we get to that, let me walk through the administrator checklist with you so you know what this tool looks like. At the top, you can see there is the scale for what you are seeing. So you would mark a 4 on the scale for each particular item that is just within the lesson component that you are observing. If you observed a particular part of that lesson component, you'd mark a 4. If you partially observed that, or the whole thing wasn't done right, there's a partial use of that, it would be a 3. If you did not observe that particular part of that lesson component, you'd say not observed with a 2. Maybe teacher skipped a component altogether. That's noteworthy. That would be a 1. NA would be not applicable for some reason. It's possible. Okay, this administrative checklist is electronic. It does mirror the lesson components, as I've said. The scale, however, because this is electronic, it's an Excel spreadsheet, you could change that scale how you would like. So in looking at the checklist here, I have lesson page 1, getting ready, right? That was the vocabulary review and the game portion of the lesson we looked at earlier. I wanted to point out that where you see the green arrows is something that is repeated with every lesson component, that the teacher provided support materials or differentiation for students, yes or no. It might be a not applicable, right? That's real possible. And that the teacher added to the math focal point or reviewed it with the students. That the teacher actually had that up and was in use would be something to talk about. So the math focal point itself is optional, but the part of the review part would be pretty essential. That should be present. So that's why that is there. So you can see how this matches up with the lesson component on the right. So these are all in order. There's Math Dash, poster cards. We're in the second half of the first page. Math Tools is after poster cards. Show and Tell is after that, right? And so on. So what we're going to do is we're going to take a look at a video today. And this video is going to be Math Dash for this particular lesson. If you recall, the student will identify two-dimensional shapes, rhombus, and rectangle. So here's Math Dash. It says the teacher needs to connect the action cards to the actions as they occur, match, sort, identify. So we know what the action cards are. It could be that these actions don't necessarily occur within the activity, or the teacher forgot. Providing that demonstration of these 3 actions can be done separately if that's what's necessary. So that's acceptable as well. Below that, the teacher places building blocks, attribute blocks, and pattern blocks, particularly rhombi and triangles on the table. And the teacher says something like this: I see two-dimensional shapes, then show the rectangle and ask what shapes can we use to make a similar shape to this one. Students move and explore the shapes to make a rectangle from squares. Ask, what can you tell me about shapes used to make this shape? Can you identify what is similar about the shapes? Place 2 squares to make a rectangle. Students answer. Repeat with rhombus. Ask, how can I make this shape? Students move and explore shapes and place 2 triangles to make a rhombus. That's the expectation, but right, you don't know what's really going to happen. When you see quotation marks here, the teacher is not obligated to use that exact quote. It should be something like that. The teacher can say it in a different way as long as the point is getting across. The reason why we put these questions and statements in quotation marks was to make it simpler for the teacher to read, get what they're supposed to do, and move on with the lesson. We wanted to make it easier for the teacher without this long explanation. And we think that does the trick. But sometimes teachers are stopped by that, like, oh, I have to memorize this. They don't. They do not have to memorize it. They just need to know what the activity is going to look like. I should point out the action dictionary here. The students are making shapes, and there may be students who are going to require some support. So this is something the teacher would think of ahead of time, right? And have this available for the students. The students, however, might have an adaptation in place for this kind of thing already. So this might not be necessary, even though the student needs something. It doesn't have to be from the action dictionary. The support here is a work mat, and then the shapes that fit on that work mat, and they do fit, right? Anything that has a shape outline is at the same size as the shapes that are included in the kit. So for example, the teacher might provide an example and say, okay, so I want to make this shape, this new shape, okay? And it doesn't look right? It's triangles aren't working. So the teacher then decides, okay, well, I'm going to use the squares, and oh, look, I made a triangle, and show the student how that works. This red line here represents either a wiki stick that's included, the wax-coated yarn sticks that are included in the kit, or it could be an angle egg, but it's a way for students to be able to create a shape and stop at the place where they need to stop. So they can push this down, or I can turn this work mat, the student can push the way that's more comfortable for them to do that. So that is a support. I can show that to my students this way as well. I can put them on this rectangle this way and have the students try to figure out putting them on a rectangle this way. That's another possibility. For the rhombus, it would be triangles. I can show, well, I used a triangle and a square, that didn't work. But let's see if I use two triangles, how that works. So I can put this down for my student, and my student can try and have the wiki sticks or angle eggs there for the student to be able to push those two triangles in to make a rhombus. So let me go a little bit too fast here for you. So this is what you're looking for in Math Dash. So in Math Dash, of course, this is the very first part of the observation is, did the teacher provide support materials or differentiation for students? Did the teacher provide required tools and materials? Did the teacher model and show action words? Did the teacher ask targeted questions? Did the teacher model the concept? Did the teacher model use of materials? Did the teacher support student understanding and promote discussion? And then there's the adds to or reviews, and the example of that would be Math Focal Point. So let's take a look at this video. I'm going to connect to it here. It's coming up. So I'm going to look at playlists and moving there. And as you have this, so you can come back to these videos. I'm going to look at the classroom videos, and the classroom video we want is 1C10, which is right here.
Cool. All right, so next we are going to be working with more shapes. More shapes. Thank you. If you can help get the shapes out of the bags.
Let's see. Can I help you?
Hey. Yeah, I see shapes. I see some shapes I know. I see squares. Squares. Two squares. Oh no. I see circles. Giant. I see triangles. Yep. Do you have? Oh, these are yours. But hey, you know, I see two shapes that we don't know. I see this shape. Can you find this shape? this shape? Where? Show me. Yep. And I see this shape. Can you guys find this shape? Yeah.
Mr. Kessel.
We're not talking about this one.
So these are two shapes that we don't know. They're new. I wonder if we can use the shapes we know to make these new shapes. Let's try it. Dretzi, can you use the shapes we know already to make this new shape?
A house.
Oh yeah, you're building a house.
Okay, so this one, we have this
Can
one.
you guys, can you
So
help
what can we do
Mohammed
to make this
make the shape with shapes we already know?
similar shape?
All right, Mohammed. So can I see these shapes? Let's see. Can we use circles to make this shape? Let's see. Can we put two circles together? Is this the same? No. No, that doesn't work. Can we put two triangles together? Does that make the same shape? No. What if we use these two shapes?
This shape. Does that fit there? Okay.
Does this, putting two squares together, make the same shape, Mohammed?
A square. That's right. It is a square.
Are these the same?
Where should we put the square?
Yes.
Here. Where should we put the square?
What can you guys tell me about the shapes we use to make this new shape?
House.
We used squares. Did we use one square?
No. Two squares.
We used two squares.
It's like 1, 2, 3, 4.
We know, Juretzi is saying we know that they're squares because we can count the sides and we can count the corners. 1, 2, 3, 4. And 1, 2, 3, 4.
Miss Elizabeth.
Yeah, but she'll be back soon. Yeah. She's
What can you tell me that is different about this new shape and a square? What's different? Two squares. Yeah.
And how many of this new shape?
Yeah.
Okay, I'll stop the video there. We'll go back to where we were our presentation here. So that was an interesting class. I do have this link for you if you want to go back and watch the rest of that. It's really good. The teacher is actually a student teacher. I thought she did a marvelous job. She is worth watching. So that is something you can connect with on our website. That will continue to be there. I can send this video by request, or you can find this or the link for the video by request. You can also find it in the curriculum resources link that was sent out by email. So let's take a look at what happened here. So when I looked at this, I'm looking at what the teacher did. It says provide support materials and differentiation for students. I did see that happen, but not to the extent that I would like to see it happen. I thought that when she was talking to the young man that was up by the corner of the table, and she was giving him choices. I thought that was a legitimate strategy. I would have liked to have seen more independence in putting those shapes together. Perhaps that she was not able to find an adaptation to support his particular needs. That's very possible. That would be a discussion point, though, I think, after an observation. Did the teacher provide required tools and materials? Yes, everybody had their shapes. It's quite a big set of shapes, so yep, everybody got one. Did the teacher model and show the action words? I really didn't see that. She did show, put the shapes together, but I really didn't see those targeted as action words and matched up with the action words. Did she ask targeted questions? Yes, she did. I thought she did a really good job of that. Did she model the concept? Yes, she did. She showed a good example and a poor example of how to make those shapes. First using circles, then using triangles, then using squares. Did she model the use of materials? Yes, she did. She did a really good job. I particularly like her wait time in between showing students things and taking a look at all the students around the table. We didn't see some of the students, but looking at the students all around the table to see who needs a little bit more support, who, who's with her, who's answering the questions. She was aware of all of that. So that was really good to see. Did she support students' understanding? Yes, she did. Promoting discussion a little bit. We saw that towards the end. Perhaps we would have seen more of that. I'm not sure if I would have given her a 2 on that. I might have maybe a 3. And 2 is probably a little low. And did she add to or review the math focal point? Well, she did review during that time, right? She talked about what the shapes were and that kind of thing. So she talked about what a square was in comparison to a triangle and a circle. So she did some review, and so I would consider that somewhat present. So if you're going into the classroom for the first time and you haven't had a chance to see a lesson, you might feel more at ease in just answering some questions, just as a first time, take a look to get the lay of the land kind of a situation. So if you want to do that, I think this is a legitimate way to monitor what the teacher is doing. I would ask the question as I'm sitting there, is the teacher modeling actions, language, and vocabulary? And if that's the case, what are the students doing? Are the students watching the teacher? Is the teacher providing hands-on materials and access, if it's appropriate at the moment? Are the teachers touching and doing? So making sure everybody is active. Is the teacher providing choices and access to those choices? So are the students choosing? Is the teacher providing opportunities and access to talk? Are the students communicating? Is the teacher providing a fun and safe atmosphere? Are the students interested? Are the students eager to try? So I think that is a good way to look at, just a spur of the moment, drop in, see what this looks like in this classroom, and maybe bring the formal page in later to look at. But all of that, of course, is up to you. So if you have any questions, you can call me at 612-270-9773. You can email me at kbrown@ablenetinc.com.